Hi, my name is Dr. Robert Coble, and I'm an associate professor here at Corning Community College. So, for many of you, I am your lecture instructor and your lab instructor. For many of you, I am not your lab instructor. However, this video serves as an introduction to the first lab. Your lab instructor will be accepting this lab at the due date, so make sure that you complete it before then and then email them the lab. So this lab is going to cover the scientific method. And the scientific method, which many of you I hope have heard before or have studied in high school or middle school or even elementary school, hopefully you're familiar with this. But if you're not, let's go over it. So the scientific method is the basis for science. I mean, all science is it uses the scientific method to understand the world around us. And I guarantee, absolutely guarantee, that you have used the scientific method before in your life. Probably, this past year with COVID, at least some points, of whether you want to wear a mask or not, what are the results of that. So we're going to go through it, the scientific method, and then I'll lead you into the lab itself. So really, the scientific method starts with an observation. This could be anything that you observe in nature, like anything at all. And so the example I'll give you as we walk through the scientific method is this one, where, maybe your car doesn't start. You wake up, if you drink coffee, you have that miraculous first sip of coffee, and then you go to your car, turn the car on, and it doesn't start. So the question that comes from that, you're sitting, and what do you think to yourself? You're probably saying some expletives like, can't say them right now, but you're probably thinking to yourself, why is this car not starting? And then you try to answer your question. So there are a bunch of reasons why a car might not start. And you can think, while I pause for a few seconds, what would you say? Like, what is your answer? Why is this car not starting? So you can think to yourself, why is the car not starting? And so for many of you, you might think to yourself, the car isn't starting. The car doesn't start because it is out of batteries. And so this leads us to a hypothesis. And a hypothesis is a proposed explanation for a set of observations. So you're basically answering your question. You're answering, like, why is the car not starting? The car isn't starting because it is out of batteries. And this leads to a few things about a hypothesis. And if you're watching this, hopefully you have notes out, because you should be writing this down. The first thing is that it has to be testable. Is this hypothesis, the car doesn't start because it is out of batteries? Is that testable? Can you test to see if the car is out of battery? And the answer is yes, you can. You can get a meter that tests how much energy is in the battery, or you could just simply switch out the battery. And if the car starts, you found out the problem is that it's the battery. It has to be falsifiable. So you could be wrong. Is this hypothesis, the car doesn't start because it is out of batteries? Is that falsifiable? Could it be wrong? And the answer is yes. Let's say you check the battery level and it's completely full. And if your car doesn't start, then your hypothesis is wrong. And that's totally fine. That's part of science. Scientists are wrong a lot, but we retest and we remake hypotheses, which we'll get to later. The last thing about a hypothesis is that it is a statement. It is a sentence. It is not a question. Oftentimes we see hypotheses as if-then, like, if the car doesn't start, then it is because the battery is empty. That's fine. That's quite elementary. Like, that's kind of the way that you would write a hypothesis, maybe early in your scientific career. But now you could just say a statement. The car doesn't start because it is out of batteries. That's completely fine. but it has to be a statement. No questions. You can't be like, is the car not starting because it doesn't have any batteries? That's not how it works. Skip that. We want to make it a statement. So once you have your hypothesis, then you can do an experiment. Your experiment in this case could be several things. You could test the battery level. You can replace the battery if you're made of money. What else can you do? You can do a different type of test where you can like replace spark plugs, and if it doesn't work, then it lends credence to it being the battery. But I think these are both good experiments to see if the battery is the reason that your car's not starting. So then you get the results. The results in this case, this example, let's say that you replace the battery. So you decide to go buy a new battery for $90 and you replace it. And unfortunately, the car still doesn't start. Bummer. So you're out $90, car doesn't start, late for class, freaking out. What are you going to do next? You're going to make a conclusion. And that conclusion is that your hypothesis is not supported. The reason that the car isn't starting is not because of the battery, it's probably because of something else. And that's totally fine. This is the last part of the scientific method, is then you're going to go back, you're going to get your conclusion, and you're going to go back and you're going to remake a hypothesis. So I'm just going to make this really thick. So at the end of it, you're going to go back and you're going to restate your hypothesis. You might make a new hypothesis. So in this case, let's see what we could do. You try to test the battery. It turns out that the battery isn't the issue, so you're going to redo your hypothesis. Let's think of another hypothesis. We can say the car doesn't start because the spark plugs don't work. Is this testable? Yes. You could test it by replacing the spark plugs. Is it falsifiable? Could it be that the spark plugs are not the reason that the car isn't working? The answer is yes, right? You could still think maybe it's out of gas. Maybe your key, like a lot of keys now are electronic, and maybe the electronics for the battery and the key isn't working anymore. Is this a statement? The car doesn't start because the spark plugs don't work. Yes, that is a statement. So, good hypothesis. What's the experiment? Well, how about this? Make it super simple. We replace the spark plugs. So you replace the spark plugs, you turn the key, and guess what? The car starts. Awesome. Now you can make it to school to take your test on time, to do the activities, or whatever. Go get tested for COVID before you go to class. You have to be tested every week if you're coming to class on campus. So it's free. Do it. Takes like 5 minutes. Anyway, so your car starts. Now that your car starts, your hypothesis is supported. Congrats. And this is the scientific method. So you were able to use the scientific method in this case to find out that the reason that your car didn't start is because of the spark plugs. Make sense? I hope this makes sense. So we are going to be doing this for this lab. So I'm going to bring the lab over. And this is what the lab will look like. It's a scientific investigation. Here are the learning objectives. And for this lab, you're going to have an introduction. Read the introduction. It talks a lot about what I just said, but it gives a little more information. It actually gives you another example. It talks about control groups and experimental groups, and please make sure that you memorize the different parts of the scientific method. You'll be tested on it. I mean, this is the basis of science, and you are in a science class, so you should probably know a little bit of thing or two about the scientific method. Uh, Follow all the directions. The first major activity that you're going to be doing for this lab is to test this hypothesis. So here's the hypothesis. It says the length of a person's upper limb is equal to 40% of the height of a person. So what I'm basically saying is that the height of your arm here, so the length from here, your armpit, all the way to the tip of your middle finger, that is 40% of your height. So we can test that, right? First of all, is it testable? Yes, you can measure people's height and arm length. Is it a statement? Yes. And could it be wrong? Yes. Maybe it's 30%. Maybe it's 50%. Maybe there is no correlation. So we're going to ask you to measure the height and the arm length of 10 different people. And you can include yourself. So in this column of this table, we want you to measure the height of a subject. And we want you to do this in centimeters. So if you have a meter stick, if you have a like a tape measure, they always have centimeters on them. So measure the height of a subject. Measure their upper limb length. Their upper limb length is, again, from the armpit all the way to the tip of the finger, middle finger. In this column, this is the expected upper limb length. So this is what you would expect if the 40% were true. So you're going to take the height. You're going to take whatever is in this column. You're going to multiply it by 40%, which is 0.4. So that would be the expected upper limb length. For example, if the height of the subject is 180 centimeters, the height would be 180 times 0.4. And so I believe that that's 18 times 4. 36, 72 centimeters. And then you would try to find the actual percent of height. So what you would do in this column is you take the upper limb length, so the measurement from the armpit to the end of the middle finger, and you divide it by the height. So that's, again, this column is the height. This is what you measured. Let's say that's 75. So you would take 75, that equals 75 divided by 180 times 100. And let me get my trusty calculator out. 75 divided by 180 times 100. 41.7%. Once you do this for all 10 people, you can then take the average of this last column, and we could see if that is 40%. If it's not, maybe you reject your hypothesis. If it is, maybe you accept your hypothesis. Once you're done with this, you're going to plot it on this graph. So here is the upper limb length, and here is the height. This is 40%. So we should see all the dots along this line. If it isn't, that's your data. Maybe you don't support your hypothesis. We're then going to ask you to design your own experiment. So we're going to ask you to try to make a hypothesis and test if something else of your body is correlated. So, for example, what a lot of people do is they say that their shoe size, so the length of their shoe equals the length of their, like from the wrist to the elbow. So you can do that. If you do, same thing, you're going to measure people's shoe length. You're going to measure people's wrist to elbow length and see if they're the same. That's fine. You can do something else. We don't care. Just make sure that it's scientifically accurate. Answer some questions and then turn it in. So I guess that's it. I know it was really fast. If you have questions, please contact your professor. If not, we'll look forward to your answers. Have a good day.